Based on observations since 1971, this study describes fundamental changes among key elements of the Arctic physical and biological systems. Associated with Arctic warming is an intensification of the hydrologic cycle, with increases in humidity, cloud cover, rainfall and snowfall, increases in Arctic river discharge, increased snowline altitude, and accelerating loss of land ice. Downward trends continue in the thickness and extent of Arctic sea ice. In concert with May-June air temperature is a decline in snow cover duration. When the snow cover sign is inverted here, the correlation is more obvious. An increase in Arctic tundra greenness correlates with Arctic warm season air temperature because tundra vegetation growth is temperature limited. Near-surface permafrost continues to warm. Warming is stronger in the Arctic than elsewhere through a process called Arctic amplification. We measure the strength of Arctic amplification by comparing the changes in Arctic and Northern Hemisphere air temperature. Cold season warming is nearly 3 times faster than that of the Northern Hemisphere. Later freeze-up of sea ice and increased flow of moisture into the Arctic are key contributors to this rise in cold season air temperature. The Arctic warm season temperature increase is still 1.7 times that of the Northern Hemisphere. The study examines ecosystem response to physical climate changes and documents numerous biophysical disruptions that have cascading effects. These include condensed plant flowering periods that can produce timing mismatches with pollinators. There is now evidence of increased ignition of wildfires because lightning increases with temperature and precipitation. The Arctic physical and biological system is now clearly trending away from its 20th century state, with implications not only within but beyond the Arctic. The Arctic Climate Indicator data series presented in this study are freely downloadable from amap.no.